Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Yes. Am I audible? Can you please confirm? Yes. Thank you participants. Yes. Am I audible? Can you please confirm? Yes. Thank you participants. Thanks for your reply. And about Pantech is an educational equipments manufacturing company. From Pantech you can get lab equipments for EEE, ECE, computer science, IT related products. You can get it. And our vision is to help 10 million students to learn the technology in easy way. So far we have trained about 10 lakh students. And today topic is switched reluctance motor speed control. Switched reluctance motor speed control. Yes. So from where it could download. See, just open your email. Yeah, I will open my email. Just select. Just second. I will show you how to download it. Yes. So let's move to the switched reluctance motor. So this motor comes under the special machines. So now let's try to understand what is SRM, how this SRM it's working, and how we can model this SRM into the MATLAB Simulink. So everything we will discuss one by one. So try to engage with the entire session, right? And so this is the switched reluctance motors widely used in electric vehicle applications. So generally this motor will have a high speed motor and also it can produce a high amount of torque, right? So this motor can deliver n number of speed. So you can, if you want to design your own design for 60,000 RPM, then it's possible to design this motor, right? But I mean, it's a kilowatt range and then speed range, everything is possible with this motor because of its simple construction as well as the working control. So if you take a electrical motors, so there are two types. One is called DC motor or commutator-less motor, and then AC motors or commutator-less motor, commutator motor and commutator-less motor. So this motor comes under that commutator-less motor and switched reluctance motor. See, what do you mean by reluctance? What do you mean by reluctance? Do you have any idea about the reluctance? So now we are going to identify the lowest reluctance path, and wherever the lowest reluctance path, then we are just switching the coil, then we can motor will get rotated. So that is called switched reluctance motor. So do you have any idea about the switched reluctance motor? What is mean by reluctance? What is meaning? What is the meaning for reluctance? So reluctance is the obstacles of magnetic field, right? So reluctance is the obstacles of the magnetic field. Similarly, if you take a resistance, so in the electrical circuit, the resistance is the obstacle for the current flow. Similarly, in the magnetic field, the reluctance is the high air gap. If the reluctance is high, then which means that there is a huge air gap. So due to that principle, the flux flow will be very less. So now you have to identify where is the very low reluctance. Now how you can identify the low reluctance path. So when out of two to three coils, if any one coil has a very low reluctance, then if you switch that coil, then automatically the rotor will align to the that particular coil, excited coil. So here you have a two word called aligned position and unaligned position. So we will discuss in detail. So all the points, please try to engage with the entire session. Right. So this is the basic history of the SRM. So initially in 1850, so SRM concept has been evolved. Right. So later AC induction motor inventions, the entire market has diverted to the AC induction motor because of its simple constructions. But in 1850s, the SRM, even though if it is the concept verified, but you need a high-end technology to execute this concept. So you need a high-end technology. So high-end technology is nothing but the power electronic concepts. So in latest, like 1960s, with the help of power electronic devices, then the Professor Peter John Larson has invented this motor like a SR drives. So this entire concept is called as a SR drives, and based on this power electronic circuit configurations, so this motor is developed and then applied for the various applications. So here you can use it for the windmill applications, you can use for the spacecraft applications, and you can use for industrial applications. And nowadays this SRM motor comes up with linear magnets also, linear motors also, right? So wherever we need fast or high speed applications, we can use this motor. Wherever we need the wherever we need a high speed applications, we can use this motor, right? And so to understand the SRM, so we must go through all the concepts, how the motor working basically. As we know the DC motor, so the DC motor Lorentz force. So if there is a magnetic field, if there is a magnetic field, if the current carrying conductor plays on the field, then what it will be? The force will be created one directions, right? So if the that will be perpendicular to the magnetic field. So this is the magnetic field directions. So this is the magnetic field directions. The force is been created in the opposite directions or perpendicular directions, right? So due to this force, then we are getting the force rotations, right? Similarly, in the mutual induction or induction motor principle, so we apply a voltage to the stator. Due to the mutual induction principle, the resultant magnetic flux will cross sects the rotor, right? So due to this, the magnetic or mechanical force has been created. So due to this, the mechanical force has been created. Similarly, if you take the reluctance force, this is the permanent coil and this is the movable part, right? So when you apply voltage to this coil, then what it will happen? The movable coil, right? So this arrangement will attach on the each side, will attach to the core, right? So if the switch is, if you apply a voltage, then it will attract. Similarly, if you arrange few more phases, then the same part. Suppose if you have same mechanisms, and similarly, if you apply this coil, then what it will happen? If you excite this coil, then what will happen? This movable part will attract with left side. Similarly, if you apply this coil, then what will happen? The movable part will attract right side. So likewise, we can change the position of the movable part. So simply we can call it as a rotor, right? So are you getting this point? What is a reluctance force? How this reluctance force working? How the reluctance force working, right? So here, if you understood the concept, then you can easily understand how the motor, switch reluctance motor working. How the switch reluctance motor working, right? So are you getting this point? If you understood the concepts, please comment in the comment box. Understood. How? What is the reluctance force? What is the reluctance force? If you understood the concepts, please comment in the comment box. Please comment in the comment box. Understood or super clear. I will repeat. See, this is the fixed coil and this is the movable part. When you apply a voltage to the fixed coil, then what it will happen? So here this part is the low reluctance part. So here the force will get created because of it's a movable part. Then it will attract and then it will connect. This part will align with this coil. Similarly, if you turn off this voltage, if you apply voltage to this coil, then what it will happen? So this movable part will get aligned with this part. So it will get aligned with this part. So likewise, if you switch left and then if you switch right, So switch for the left. If you switch left for the some time, and then after that, if you switch the right core, then automatically the movable part will slides each other, right? So the same concept we are going to just apply it to the motor. So if you take a see here, so this is the basic SRM motor concept constructions, and see here we can take this is 6-pole stator. See here the pole stators are about 6 numbers. Stator poles are 6 numbers, and then rotor poles are the 4 numbers, right? So this is the 4 numbers. The red color denotes that rotor, and it has a 4 poles. And in the stator pole, we have a phase windings. So we have a phase winding. So now you can understand this position. Rotor and then stator has aligned some of the phases. That is called aligned rotor position. So this portion is called aligned rotor position. Similarly, the rotor and then stator, some phases is not aligned, right? So like that, the rotor has been designed. So this is called unaligned rotor position. So this is called unaligned rotor position. What is the what is that aligned position? Rotor and then stator poles aligned each other, then we can call it as aligned rotor position. If it is not aligned each other, then we can call it as unaligned rotor position, right? Right? If you have any questions, yes, let's move to the next one. And see here, if you switch the phase windings, then the rotor will try to rotate, and wherever or which coil excited, so the rotor will get aligned with the coil, and then remaining coil will be moved to the unaligned position. And after that, if you switch the next phase, then what will happen? That phase will get aligned, and the remaining phase will get unaligned position. So like that, we can rotate in the similar manner, right? So here how to understand the windings, and then how to understand the inductance profile, right? So if you want to understand the aligned or unaligned position, you must understood the SRM inductance profile. So you must know how to draw the inductance profile also, right? So just to take SRM motor, that means switch elements motor. So here the A phase, B phase, C phase. So this 3 phases has been developed, and if you take a winding, right? So this is that winding terminal. So this is our next terminal. If you connect multimeter, so not a multimeter, LCR meter. Do you know what is LCR meter? So LCR, with the LCR similar like multimeter. So the LCR meter will help you to measure the inductance of the particular coil. Inductance of the particular coil. Just search in the Google. Search in the Google LCR meter. See here, this is the LCR meter. So by default, second I will show you how to fix the mode. Yes. So see here, this meter will help you to measure inductance and the capacitance and then resistance. So these three components you can measure it with the help of this meter, and so now you have to connect this LCR meter with across the terminal, right? So across the terminal you have to measure it. So you have to connect across the terminal. So now what will happen? So now manually you have to switch the rotor, right? So here this is the rotor diagram has been mentioned. Just a second. So now, for example, see actually my LCR meter has connected phase A terminals across the terminal. Now you have to rotate the rotor. So from original position to aligned position. For example, if you take this is the 0 degree, if you take this is the 0 degree. So for the 0 degree, what is the L value? And similarly, slightly you have to adjust the rotor from 0 position to 2.5 degree, 5 degree, 7.5 degree, or even you can change 1 degree also. For 0 degree, 1, 2, 3, 4, up to you have to develop about 90 degree. You have to measure the inductance for the 90 degree. The stator is fixed. You just connect LCR meter across the winding and just rotate the rotor alone. Manually you have to just rotate. So that part you have to do with accurately, like each and every step must be equally you have to change. So for that one, you just go to the our website, Google, just search Google SRM code. I will share you the working principle. See, for example, just to take this motor, I will share you. The site is not properly loading. Here, if you change the motor, see, I will show you one document. Just a second. See, actually, manually you have to rotate the motor. See, for example, if you take this video, yes. So just to take this graph, see, for example, just a second, I will show you. See, for example, here the degree has been placed. So manually you just rotate the rotor for each and every degree. So this meter will give you the inductance value. So this meter will give you the inductance value. So now you have to take the value. Now you have to take the value, right? So I have that readings also. You can download the Excel sheets from the file also, like from internship portal. You can download that Excel value. So that is that we will calculate generally how to calculate the SRM motor and all. I mean SRM motor induction. I mean SRM motor inductance profile. And I special notes, right? So I will share you the image of that position, how to draw and then how to fix your motor. I will share you some after some time, right? And now see how to calculate this value. So by just use this LCR meter and connect the across the winding, and then now you have to change the rotor, then you may get a value like this. So now if you draw the value exactly, then the shape of the value, inductance value will be like this. So sometimes it will be low, and then sometimes it will be high, and after the sometime it will get it will get down, and again it will be low. So like that, if you draw for all the phases, so you have to draw for all the phases, then you may get you may get a inductance profile like this. So from this graph, you can easily understand where is the rotor is aligned with the stator and where that rotor is not aligned with the stator, right? I will tell you. See, wherever the air gap is low, then that is called aligned position. Wherever the air gap is high, then we can call it as an unaligned position. And see here from this graph, you can understand. See here, this is the aligned position. So now the rotor is aligned with the A phase. Similarly, in the graph we we are getting like this, right? So low value and then high value. I mean, it's increasing inductance and then decreasing inductance, and again it's low value, right? So this area, right? So this area is called increased phase, which means that so entering to the aligned one. So this rotor is entering into the aligned one, and so this side is the unaligned portion. So here unaligned with the leaving position, unaligned with the leaving position. So like that you can understand. So this area denotes that aligned area, and the increased value of the inductance is called enter to the aligned one, and decreasing of the inductance value denotes that relieving from the aligned position to unaligned position, right? So this is the simple behaviors from this graph you can easily understand, and now how to enable the switches. So how to enable the phases, or how to excite the phases, where at what instant we have to excite and which phase, right? So first you should understood see from the inductance profile from minimum position to maximum position, right? So this is the excitation area. So here if you apply a voltage, then that rotor will get aligned. Similarly you have to select this area. So like that you have to select the computation sequence. In the people we will call it as a computation sequence. So here only you have to fix. So now you have to construct a rectifier or converter or SR drive, switch reluctance motor drive. So that motor will that drive should generate a excitation voltage. That drive should generate a excitation voltage. So that excitation voltage will work and then will pull the rotor from unaligned position to aligned position. So if you repeat the process, then the rotor will get continuous 360-degree rotations. The rotor will get continuous 360-degree rotations. So this if you if the switching frequency is high, then based on the switching frequency the rotor will get aligned. So here also the motor will rotate based on the supply frequency, based on the supply switching frequency, right? Is it clear? Is it clear? If you clear, please comment in the comment box. Super clear. If it is clear, so please comment in the comment box. Super clear. If you understood the concepts, please comment in the comment box. Super clear. Yes. I'm just waiting for your reply. Thank you, Rakesh. Thank you, Wag. Thank you, Azaruddin. Thank you, Dabarshi. Thank you. So now let's move to the next topic. So how you can control the speed, how you can increase the speed under. So there are a few methods are there. So similarly, you can advance the computation angle slightly. Instead of 30 to 60, you can increase 25 to 55. Then the motor control speed will be huge. So you can get variable variations in the motor speed, and now you have to select you have to design a power electronic circuit to switch the motor. So simply if you take an SRM motor, so already I told you this is the three-phase motor. So generally for this one 6x4-pole machine will have a 3 phases. So the motor will be like this. So there will be 6 terminal, right? And so this 3 winding will be there, and the rotor will of course the rotor will be there. So in the stator will have a 6 terminals. So now you have to apply a voltage, right? So simply just apply a voltage, then this coil will get excited. So now you have to identify a proper power electronic circuit to switch on the particular sequence, and also it should be a evenly you have to you have to apply a voltage. It should not be uneven sequences. So let us discuss how to design a converter, and then how to generate a PWM, and then finally how we can control the current. So this three things we will discuss in the MATLAB Simulink. So just please wait. I will share with the things. And see, I already told you. So here, if you take a three phases, so this is the Y phase, G phase, and then B phase. You can name it A, B, C, whatever you want. You can name it. And this is the special power electronic circuit. So switch 1 and then switch 2 will help A phase to excite. So you have to excite you have to apply the same PWM for S1 and then S2. Then only the current will flow like this, right? And the energy will be stored in the inductor, so that will be dissipated with the help of this diodes. So generally you have to select this diode as a Schottky diode. So because the frequency we are going to use it about 25,000 or 50,000 or 100 kilohertz switching frequency. So this diode should respond for that frequency, right? And similarly, if you operate the PWM for the S3 and then S4 at a time, then this phase will get excited. And similarly, if you apply a PWM for the S5 and then S6 at a time, then the third phase will get excited. The third phase will get excited. So now you have to apply a PWM. If you draw the PWM sequences, so PWM for the S1 and then S2, and after that S3 and then S4, and after that S5 and then S6. So now again you have to repeat from the second position, right? So if you repeat the sequences again, then you may get a continuous rotations in the motor side. Is it clear how to switch the PWM to the coil? Is it clear? How can we increase the angle of the wave shown in the graph? See here, you cannot increase or decrease the angle. You have to work with the PWM converter only. You have to identify this position. So this PWM should match with your inductance profile. For example, if you take this one, so the inductance profile must be like this. So I will color it in the different. See, for example, if it is a 1, then the A phase inductance must be like this. So here the B phase will be like this, and then C phase will be like this. So here this angle we can identify with the help of rotor position sensor. So this angle we can identify from the rotor position sensor, right? Thank you, participants. So no, the short circuit will not happen, because here the short circuit will not happen. Right? Thank you, participants. Thanks for your comment. So the diode is to dissipate the energy stored in the inductor. So the diode is help us to dissipate the energy stored in the inductor. So like that, you have to generate the PWM. See, for example, so A phase this is that unaligned to aligned position. So due to this one, we have to excite this one. Similarly for the B phase and then C phase, right? And so now how we can fix the how this rotor will align to unaligned one. So now if you take this construction, so now we are going to take a voltage. For example, if you apply a B phase voltage to the B phase, then what it will happen? The rotor will get aligned. So the rest of the two phases will not align to one. And if you apply a C phase, then C phase will get aligned each other. Right. Yes. So C phase has connected, and similarly for the A phase, the A phase has connected. So like that, if you repeat the same process, then you will get a continuous rotations, right? And now let's move to the MATLAB. Yes. Do you have any questions about the working principle? Do you have any questions about the working principle? If you clear, so please make comment in super clear. Yes. If you have any questions about the working principle of the SRM, please comment in the comment box. Super clear. You have to identify the nearest aligned position. Thank you, participants. Raj, who have not understood, so please repeat the view. Why the curve response is short? So actually, I have drawn as a ideal graph, but in the practical, it will not be like that. So there will be some saturations. Yes. So when two switches are off, then how the current flows diode? See, actually, the diode will help us to avoid the peak overshoots on the particular coil. On the particular coil. Any disadvantages like a power loss? Yes, there are some few disadvantages available in the. I mean, it's there in the about in the SRM. I will tell you. So try to engage the entire session. Try to engage the entire session. Thank you, participants. Dear participants, please allow me to show you the demo. So I will share you the utterance form. Please wait. Don't rush up. I will share you the utterance form. So please wait. And if you have any more questions about the working principle, so that we can move to the hardware, sorry, simulations. How to select a diode switch in inductor? See, that's why you have to identify the rotor position. The help of sensor. If you have any more questions, you please ask me. I will try to give you the solutions. Thank you. So let's move to the next one. So I'm just opening to the. Are you ready for the MATLAB demo? Are you ready for the MATLAB demo? So if you are ready, please comment in the comment box. If you are ready, please comment in the comment box. Yes, thank you, Janardhanan. So let's move. I'm moving to the MATLAB. To just the MATLAB, you have a the motor you can identify in the MATLAB Simulink some power system block sets. So just open the library browser and go to the Simscape, open the electrical, go to specialized power systems and then fundamental blocks to machines. So here you can get a switch reluctance motor. The switch reluctance motor and then stepper motor are almost same working principle. Slight difference will be there, but same working principle. Right? So here, see here the number of phases you can select how many numbers you can choose it. 2 by 6 by 4, 8 by 6, 10 by 8. So these are all the motors you can choose it, and just keep other things other same as it is, and you can use for the similar one, right? So I have selected the same one, right? So this is the A phase, and similarly B phase and then C phase. So initially you may not aware of that where the phase is excited and then how the rotor position is as excited. So everything you should understood, and step by step how from the scratch how to develop the converter and then how to identify the rotor angle, everything we have given in the internship link. So their time is very limited. So people keep on asking the attendance form. So just a second, I will share you. I will share you the attendance link. Yes, I shared the attendance link. So please submit your attendance form that others won't disturb others. Will won't disturb. I have shared the attendance form. So please submit your attendance form. Right. So now I will move to the demo. See here, this is the complete simulation of the voltage control for the SRM motor. And first we have developed the phase control, that is the power converter. So as per the circuit diagram we have developed, and here in between these two legs we have to connect the inductance, right? So in between these two legs we have to connect the inductance. So this is the A phase, and similarly this is the B phase, and this is the C phase, right? So each and see here the pulses for the each phases are the common PWM. Pulses for the each phase are the common PWM, right? So for the top switch as well as the bottom switch is the common. So here we have selected. So from this one we have to understood the rotor working principle. So for that one we need a rotor angle, right? So rotor, where is that rotor position? I mean how to understand the rotor, right? So for that one, so here we are taking the rotor. So the last signal is that omega, that is called speed sensor. So the motor speed sensor is available on the fifth signal. So this signal we have developed, and generally this will be in the radian. So we have to convert to the theta. So we have to convert to the theta. So the theta nothing but, so from this rotor speed only we can identify the rotor position. So where is the 0 or where is the 30, where is the 60 and all, right? So here this is the calculations to convert radian per second to theta conversions, and after that this is the discrete time integrator. Will enable the name. So this block will help us to identify the data like a theta. See here this is the generalized speed in the radian, and here we are converting into the here we are converting into the theta, and this theta is linear. I mean it's started, but here we have to linearly we have to generate it. So we have to generate as a linear one. So for that one we are using this block, and once if it is applied, then we have to take a modulations like for the entire 360 degree we have to separate into 4 because the rotor pole is 4 poles, right? So each and every 90 degree is the same for the next 90 degree. First 90 degree position will be same for the next 90 degree. So for that purpose we applied this one, and so within that 90 degree we have to take a 0 to 30 for one phase, and then 30 to 60 for the next phase, and then 60 to 90 for the third phase. So if you excite in this sequences, then you may cover the entire 360-degree, right? So here the phase advancement you can keep it 90, 60, and then 90 and all, you can have it. So we are just disabling or doing the logic, similar logic, how to generate PWM and all. Just follow the passes. And see here we are applying the current control. Here we are applying the current control. So this current control, the maximum current will be like 50, and the minimum current will be 30. So within this current, within this limit, the MOSFET will get switched on, right? And after that, here the PWM. So this PWM we have to apply as a constant one. So this is the PWM. 5000 kilohertz has been switching clause is used, and then duty cycle is 75%. If you vary the duty cycle here, then you can control the motor speed. So this is very basic open loop control of the switch reluctance motor. So further we can go for the closed loop. Closed loop control mechanisms to apply the induction motor, EV applications. So further and all you may get, and then from this point you can start your research and all, right? So if you run the simulations, then you may get see here, this is the speed curve, and this is the voltage curve, and then a flux curve, and current curve. So this is the similar thing you may get it, and the torque variations. So the major disadvantages of the induction motor is SRM motor is the vibrations, because this motor will generate huge vibrations, because suddenly we are switching on, suddenly we are switching one phases, and then we are changing the next phases. Then the rotor will move from its original. The rotor should work on its moment of inertia. So that due to that behavior, the motor will create a huge vibrations and also heavy noise. So this is the noise levels. From this graph you can understand. So if you take a PMSM, the torque will be very smooth. But in the SRM, the torque noises are there. But to avoid this, for avoiding these noises, you have to implement a lot of PE controllers to regulate the noises. Even though if you apply the logics, PE controller, then still the noises also will be there, right? So like that, you can just go through this logic, and so this demo is basic demonstration about the SRM. Similarly, in the MATLAB in the internship portal, we have applied a few more. Yes. We just download all the projects from the portal. So if there is any internship users, please open the MATLAB. Here you can go step by step how to develop motor. See actually all the controllers. So these 3 files has been uploaded. So you just download, and try to explore all the new each and every step by step project development, right? So if you have any questions, you can ask me. Yes. So this is the advantages and the disadvantages. Advantages, everything is that huge advantages: single excitation, and then excellent power, extended constant power region, and then simple constructions. No magnetic materials are required. Whereas in the PMSM we need a magnet. Whereas here the magnetic materials doesn't required. And disadvantages basis. This is the disadvantages: noise, vibrations, and then torque, ripple. So we need precise controller. So these are all the huge disadvantages about the SRM motor. How to convert subsystem? Just open the file. Yes. So just select. For example, if you want to convert this as a subsystem, So just select this block. Just select this block and click Control plus G. Then it will convert as a subsystem. Motor torque. See, actually, this motor will have a huge torque ripple. Huge torque ripple because because of the switchings and the inductor. The three coils are the three type of inductors. So whenever you switch the inductor, then what is the inductance behavior? The inductor will store the energy and then it will dissipate the energy, right? So if you absorb the entire inductance energy to the rotor, then there will not be a energy stored. But obviously the magnetic material will have some residual energy. So that residual energy will create a spikes in the rotor current. Due to the rotor current, the torque will get huge disturbances. Torque will be high. Generally, the torque will be high. Yeah, that's it. So due to the magnetic behavior of the inductance, then the torque is so much disturbance. And then we can run this motor at a high speed. So that high speed also will create a disturbances. How to reconvert a subsystem into single component? If you want to do that one, see, for example, so if you take this subsystem, so just take all the component, just to select the component and paste it here. And now you can remove this one. So like that only you can do. Otherwise, if you continuously if you are doing, then you just undo the process, then you may get a reconversion. How to select a motor for the vehicle? I will tell you with the clear information. So please engage the entire class. Which type of magnet is best for the motor? Neodymium magnet. That magnet will give you huge size. When first phase is off, then the second phase is on. Then on, but how the diodes in the first phase will dissipate inductor energy? See, that will not be available on the entire period. It's on the it's very fraction of second. So it will be in the very fraction of second. Thank you, participants. If you have any more questions, you please comment. If you have any more questions, please ask me. Otherwise, you can post your questions to this video on comment box. I will give you the solutions. This is my WhatsApp number. Take. Thank you, participants. Thanks for your valuable time. So we'll meet you in the next class.